Hey math kids, today we're going to talk about series and we are in section 5F and looking at example 22. So all a series is when you take a sequence and you add it up. And so on this one we have 1, 4, 9, 16, 25. It says write down an expression for S sub n. And so all it wants us to do is notice that this is really just 1 squared plus 2 squared, 3 squared, 4 squared, plus 5 squared, plus dot dot dot, because this one goes on forever. And then it wants us to be able to write a summation representing that. And so we're just squaring something each time. This symbol means we're going to add all of the terms, and we are just going to go from k equals 1 to n. So this yellow thing is our final answer, but I'm going to explain it just a little bit better. So if we started with this would say first plug in a 1 for k and then do what it says. So 1 and then square. Then move to the next natural number, which is 2. And so 2 squared. Then move to the next one, 3, and dot 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 until we get to n squared. Then this symbol, which is a capital sigma or a summation symbol, tells us that we need to add all of those answers. And so we see that this starts to become the same thing. Now sometimes we'll have it finite, so we will stop at a value. So for example, if that was a 5, we would say 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, and then we'd actually square all of those and then add them together and get a number. Okay, all right, let's move on to example 23. Or, no, sorry, there is a second part to this one. So, second part, it says find S sub n, for n equals 1, 2, 3, 4, and 5. So 1, 2, 3, 4, and 5. Okay, so that explanation I did in pink right here applies heavily to this. So S sub 1 is just 1 squared, which is 1. S sub 2 is going to be 1 squared plus 2 squared, meaning we just do the two terms, which is 1 plus 4, which is 5. S3, we do the first 3 terms. And so that's going to be 1 plus 4 plus 9, which is 14. S sub 4 and S sub 5. So we're going to say 4, which is 1 plus 4 plus 9 plus 16, which is 30. And then this will be 1 squared plus 2 squared plus 3 plus 4 plus 5, which is 1 plus 4 plus 9 plus 16 plus 25, which is 55. Okay, so that finished out example 22. Now we can move on to example 23. I need some more room. Okay. This one says expand and evaluate. And so we're given the summation to start out with. So we'll do that. So remember, we plug in a 1, so we're going to get 1 plus 1. Then we plug in a 2, so we get 2 plus 1. Then we plug in a 3, then a 4, then a 5, then a 6, and then a 7. Okay? And then this symbol tells us to add all those together. And then it's just up to our simplification. So 1 plus 1 is 2. This is 3. This is 4. This is 5. This is 6. This is 7. This is 8. And so we just need to add all those together. So we get 5 plus 4 plus 5 plus 6 plus 7 plus 8. So those will be 10, so that's 14 for those ones. Plus another 6 would be 20, 27, and then 35. So the answer to that one is 35. And we have another one where it's 1 over 2 to the k. So we do 1 over 2 to the 1, plus 1 over 2 to the 2, plus 1 over 2 to the 3, plus 1 over 2 to the 4, plus 1 over 2 to the 5. So we stop at 5 because the 5 is on top. So if we simplify this, it's 1/2 plus 1/4 plus 1/8 plus 1/16 and 1/32. We can get common denominators. So this one would have to be multiplied by 2 over 2. This one would be 4 over 4. We're trying to make everything 32. This one would be 8 over 8. And this one would be 16 over 16. So we have 16 plus 8 plus 4 plus 2 plus 1 all over 32. And if we add all those together, we get 31 over 32. Okay, we just have one more. So we have, we're given this. This is example 24. It says, then write the expansion again underneath, but with the terms in, so it wants us to expand this. And so to do that, we're going to plug in a 1. So we go 2 times 1 is just 2. Then we plug in a 2, so we get 4. And then a 3, we get 6. And we go on forever like that, where we plug in 2n minus 2 plus 2n. Now this part's kind of confusing, right? Because we just plug in the n, but this is just showing that we were growing by 2 each time, and so the one right before this needed to be less than 2, because if we do this plus 2, we get here. Don't worry too much about it. If you wrote yours without this piece, you're fine. Okay, and now it wants us to just write it in reverse order, and so we're going to say 2n plus 2n minus 2, and then 2n minus 4, because we're dropping by 4 because we're going backwards. And then it's just 4, and then 2. Okay? Now the next part says, add the terms vertically, and hence write an expression for the sum s of n of the first n even integers. Alright, that is really confusing, what it's asking for. So I'll show you what they did. So if it just wants us to add what we had, essentially, and eventually we will end up with a formula for figuring this thing out. And so if we have 2, let's see, what am I trying to do? N k equals 1, 2k. So we had 2 of those because we added the 2 vertical things. And then if we add these ones, we get 2n plus 2. If we add these ones, we get 2n plus 2. If we add these ones, we get 2n plus 2. So let me just explain this a little bit better. So this is technically equal to, and then this is also equal to the same thing. 2k. So we just added these, so there's 2 of the exact same one. That's why there's a 2 out in front right here. And then I'm adding these together to get this, these together to get this, these together to get this, and so on. Now I'm going to add these. So this one plus this one. So we're going to have our dot 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 plus 2n plus 2. And then when we add 2n and 2, we get the same thing, 2n plus 2. So notice how we have a bunch of 2n plus 2's. And so one way to think of this is we have n number of 2n plus 2's. So if we kept adding these n times, we would get n 2n plus 2. That's where we'd end up. And then we still have this equal to this thing. Okay. And now we can factor out a 2 from right here. So we can take these 2's out. And so we get 2n, n plus 1 is equal to that thing. And then what we're going to do is we're going to divide both sides by 2. Divide both sides by 2. So those 2's cancel, those 2's cancel. And so we're left with the original. This thing is the same thing, the original, and that is equal to n plus 1. And then if you really wanted to take it one step further, you could. The book doesn't do this, but it could be n squared plus n is equal to that. So either this one or this one, doesn't matter. Those are both good. That's everything for this video. If you need additional help, come to Math Lab and Calculator.